think like I had a tweet earlier where I kind of like said something along the lines of, to get the most out of the tools that have become available now, you have to remove yourself as the bottleneck. You can't be there to prompt the next thing. You need to take yourself outside. You have to arrange things such that they're completely autonomous. And the more how can you maximize your token throughput and not be in the loop? This is the goal. And so I kind of mentioned that the name of the game now is to increase your leverage. I put in just very few tokens just once in a while, and a huge amount of stuff happens on my behalf. And so auto research, like I tweeted that, and I think people liked it and whatnot, but they haven't like maybe worked through like the implications of that. And for me, auto research is an example of like an implication of that, where it's like, I don't want to be like the researcher in the loop, like looking at results, etc. Like I'm holding the system back. So the question is, how do I refactor all the abstractions so that I have to arrange it once and hit go? The name of the game is how can you get more agents running for longer periods of time without your involvement, doing stuff on your behalf. And auto research is just, here's an objective, here's a metric, here's your boundaries of what you can and cannot do, and go. And
you were surprised at its effectiveness.
Yeah, I didn't expect it to work because I have the Project Nana chat. And fundamentally, like, I think a lot of people are very confused with my obsession for like training GPT-2 models and so on. But for me, training GPT models and so on is just a little harness, a little playground for training LLMs. And fundamentally, what I'm more interested in is like this idea of recursive self-improvement and to what extent you can actually have LLMs improving LLMs. Because I think all the frontier labs, this is like the thing for obvious reasons. And they're all trying to recursively self-improve, roughly speaking. And so for me, this is kind of like a little playpen of that. And I guess I'd like tuned NanoChat already quite a bit by hand in a good old fashioned way that I'm used to. Like I'm a researcher. I've done this for like, 2 decades. I have some amount of like, what is the opposite of hubris?
Earned confidence.
Okay. Yeah. I have like 2 decades of like, I've trained this model like thousands of times of like, so I've done a bunch of experiments. I've done hyperparameter tuning. I've done all the things I'm very used to and I've done for 2 decades.
Yeah.
And I've gotten to a certain point and I thought it was like fairly well tuned. And then I let auto research go for like overnight and it came back with like tunings that I didn't see. And yeah, I did forget like the weight decay on the value embeddings and my atom betas were not sufficiently tuned and these things jointly interact. So like once you tune one thing, the other things have to potentially change too. I shouldn't be a bottleneck. I shouldn't be running these hyperparameter search optimizations. I shouldn't be looking at the results. There's objective criteria in this case. So you just have to arrange it so that it can just go forever. So that's a single sort of version of auto research of like a single loop trying to improve. And I was surprised that it found these things that the repo is already fairly well tuned and still found something. And that's just a single loop. Like these frontier labs, they have GPU clusters of tens of thousands of them. And so it's very easy to imagine how you would basically get a lot of this automation on smaller models. And fundamentally, everything around like frontier level intelligence is about extrapolation and scaling laws. And so you basically do a ton of the exploration on the smaller models, and then you try to extrapolate out.
So you're saying our research efforts are going to get more efficient. Like we're going to have better direction for when we scale as well, if we can do this experimentation better.
Yeah, I would say that like the most interesting project and probably what the frontier labs are working on is, you experiment on the smaller models. You try to make it as autonomous as possible, remove researchers from the loop. They have way too much. What is the opposite of
earned
way
confidence?
Too much confidence? Yeah, they don't know. They shouldn't be touching any of this really. And so you have to like rewrite the whole thing because right now, I mean, certainly they can contribute ideas. But okay, they shouldn't actually be enacting those ideas. There's a queue of ideas, and there's maybe an automated scientist that comes up with ideas based on all the archive papers and GitHub repos, and it funnels ideas in, or researchers can contribute ideas, but it's a single queue, and there's workers that pull items, and they try them out, and whatever works just gets sort of put on the feature branch, and maybe some people like monitor the feature branch and merge to the main branch sometimes. So yeah, just removing humans from all the processes and automating as much as possible and getting high tokens per second throughputs. And it does require rethinking of all the abstractions and everything has to be reshuffled. So yeah, I think it's very exciting.
If we take one more recursive step here, when is the model going to write a better program MD than you?
Yeah. So program MD is
we're
like...
not in the loop.
Yeah, exactly.
Yeah.
So program MD is my crappy attempt at describing like how the auto researcher should work. Like, do this, then do that, and then try these kinds of ideas. And then here's maybe some ideas like look at architecture, look at optimizer, etc. But I just came up with this in Markdown, right? And so, yeah, exactly. You want some kind of an auto research loop maybe that looks for, you can imagine that different program.mds would would give you different progress. So basically, every research organization is described by program MD.
Yeah.
A research organization is a set of markdown files that describe all the roles and how the whole thing connects. And you can imagine having a better research organization. So maybe they do fewer stand-ups in the morning because they're useless. And this is all just code, right? And so one organization can have fewer stand-ups, one organization can have more, one organization can be very risk-taking, one organization can be less. And so you can definitely imagine that you have multiple research orgs, and then they all have code. And once you have code, then you can imagine tuning the code. So 100% there's like the meta layer of it.
Did you see my text about my contest idea? My contest idea was like let people write different program MDs, right? And so for same hardware, where do you get most improvement?
Oh, I see.
And then you can take all that data and then give it to the model and say, write a better program MD.
Yes. Yeah, exactly.
We're going to get something better. Like there's no way we don't.
You could 100% look at where the improvements came from and like, can I change the program MD such that more of these kinds of things would be done? Or like things that didn't work.
Just meta optimization.
Yeah, you can 100% imagine doing that. So I think this is a great idea. But it's like, I think like you sort of go one step at a time where you sort of have one process and then second process and then the next process. And these are all layers of an onion. Like the LLM sort of part is now taken for granted. The agent part is now taken for granted. Now the claw-like entities are taken for granted. And now you can have multiple of them. And now you can have instructions to them. And now you can have optimization over the instructions, and it's just like it's a little too much, But I mean, this is why I guess the psychosis is that this is like infinite, and everything is skill issue, and that's why I feel like, that's just coming back to this is why it's so insane.
Okay, well, if we're just trying to like diagnose the current moment and what is a relevant skill right now, what do you think is the implication that this is the loop we should be trying to achieve in different areas, and that it works, right? Like create the metric or create the ability for agents to continue working on it without you.
Yeah.
Do we still have performance engineering? Like what?
Yeah. I mean, so there's a few caveats that I would put on top of the LM psychosis. Number one, this is extremely well suited to anything that has objective metrics that are easy to evaluate. So for example, like writing kernels for more efficient CUDA, code for various parts of a model, etc., are the perfect fit. Because you have inefficient code and then you want efficient code that has the exact same behavior, but it's much faster. Perfect fit. So a lot of things like are perfect fit for auto research, but many things will not be. And so it's just, if you can't evaluate it, then you can't auto research it, right? So that's like caveat number one. And then maybe caveat number two, I would say is, we're kind of talking about the next steps and we kind of see what the next steps are, but fundamentally the whole thing it's still kind of like bursting at the seams a little bit, and there's cracks and it doesn't fully work. And if you kind of try to go too far ahead, the whole thing is actually net not useful, if that makes sense. Because these models still are not, they've improved a lot, but they're still like rough around the edges is maybe the way I would describe it. I simultaneously feel like I'm talking to an extremely brilliant PhD student who's been like a systems programmer for their entire life and a 10-year-old. And it's so weird because humans, I feel like they're a lot more coupled. Like you have, everything
you wouldn't encounter that combination.
This jaggedness is really strange, and humans have a lot less of that kind of jaggedness, although they definitely have some. But humans have a lot more jaggedness. The agents have a lot more jaggedness, where sometimes I ask for functionality and it comes back with something that's just totally wrong, and then we get into loops that are totally wrong, and then I get so frustrated with the agents all the time still, because you feel the power of it, but you also they're still it does nonsensical things once in a while for me still as well.
I get very annoyed when I feel like the agent wasted a lot of compute on something it should have recognized was an obvious problem.
Yeah. I think some of the bigger things is maybe what's underneath it, if I could hypothesize, is fundamentally these models are trained via reinforcement learning. So they're actually struggling with the exact same thing we just talked about, which is the labs can improve the models in anything that is verifiable, or that has rewards. So did you write the program correctly, and do the unit tests check out, yes or no? But some of the things where they're struggling is for example, I think they have a tough time with nuance of maybe what I had in mind or what I intended, and when to ask clarifying questions. It's just anything that feels softer is worse. And so you're kind of you're either on Rails and you're part of the super intelligence circuits, or you're not on Rails and you're outside of the verifiable domains, and suddenly everything kind of just meanders. Maybe another way to put it is if you go to state-of-the-art model, ChatGPT, and you ask it, tell me a joke. Do you know what joke you're going to get? There's the joke.
the joke. I do feel I can't tell you like the standard form of it, but I do feel like ChatGPT has like 3 jokes.
Yeah. So the joke that apparently all the LLMs like laugh the most is, why do scientists not trust atoms?
Okay.
Because they make everything up.
Okay.
They make everything up.
Yeah.
So this is
Why
still
did that emerge?
So this is the joke you would get like 3 or 4 years ago, and this is the joke you still get today.
Okay.
So even though the models have improved tremendously,
Yeah.
and if you give them an agentic task, they will just go for hours and
Mhm.
move mountains for you.
Mhm.
And then you ask for like a joke, and it has a stupid joke, a crappy joke from 5 years ago,
Mhm.
and it's because it's outside of the RL.
Mhm.
It's outside of the reinforcement learning. It's outside of what's being improved. It's like, and it's part of the jaggedness of like, shouldn't you expect models as they get better to also have like better jokes or more diversity of them? Or it's not being optimized and it's stuck.
Do you think that that implies that we are not seeing like generalization in the sense of like broader intelligence of joke smartness being attached to code smartness?
Yeah, I think there's some decoupling where some things are verifiable and some things are not, and some things are optimized for arbitrarily by the labs depending on like what data went in, and some things are not. And
But
yeah.
I mean the premise, there's a premise from some research groups that if you are smarter at code generation or in these verifiable fields, you should be better at everything.
Yeah.
And like the joke situation suggests that that's not happening in all fields.
I don't think that's happening.
Okay.
Yeah, I don't think that's happening. I think maybe we're seeing like a little bit of that, but not like a satisfying amount.
Yeah.
Like,
that jaggedness exists in humans. You can be very, very good at math and still tell a really bad joke.
Yeah, that's true. Yeah. But it still means that we're not getting like, the story is that we're getting a lot of the intelligence and capabilities in all the domains of society like for free as we get better and better models. And it's not like exactly fundamentally what's going on. And there's some blind spots and some things are not being optimized for. And this is all clustered up in these neural net opaque models, right? So you're either on rails of what it was trained for and everything is like you're going at the speed of light, or you're not. And so it's the jaggedness. So that's why I think like, even though the progression is obvious, what should happen, you can't let it fully go there yet because it doesn't fully work, or it's a skill issue and we just haven't like figured out how to use it. So, it's hard to tell.
Can I ask kind of a blasphemous question, which is like, if this jaggedness is persisting, and it's all rolled up in a at least monolithic interface, right? But single model. Does that make sense, or should it be unbundled into things that can be optimized and improved against different domains of intelligence?
Like unbundling the models into multiple experts in different areas, etc.
More directly, yeah. Instead of just MOE that we have no exposure to, because that can be like confusing as a user from the outside, which is like, why is it so good at this but not at this other thing?
Yeah, I think currently my impression is the labs are trying to have a single sort of like monoculture of a model that is arbitrarily intelligent in all these different domains, and they just stuff it into the parameters. I do think that I do think we should expect more speciation in the intelligences. The animal kingdom is extremely diverse in the brains that exist, and there's lots of different niches of nature, and some animals have overdeveloped visual cortex or other kind of parts, and I think we should be able to see more speciation. And you don't need like this oracle that knows everything. You kind of speciate it and then you put it on a specific task, and we should be seeing some of that, because you should be able to have like much smaller models that still have the cognitive core, like they're still competent, but then they specialize, and then they can become more efficient in terms of latency or throughput on specific tasks that you really care about. Like if you're a mathematician working in Lean, I saw, for example, there's a few releases that really like target that as a domain. So there's probably going to be a few examples like that where the unbundling kind of makes sense.
One question I have is whether or not the capacity constraint on available compute infrastructure drives more of this, because efficiency actually matters more, right? Yeah. Like if you, financing aside, though financing is involved in all of this, if you have access to full compute for anything you do, like leaving one single model, right? But if you actually feel pressure where you're like, I can't serve a model of massive size for every use case, like, do you think that leads to any speciation? Does that question make sense to you?
The question makes sense, and I guess like what I'm struggling with is I don't think we've seen too much speciation just yet, right?
No,
we're seeing a monoculture of models.
Yeah.
So
and there's like clearly pressure for like, make a good code model, put it back in the main, merge again.
Yeah. even though there already is pressure on the models.
I guess perhaps I feel like there's a lot of very short-term supply crunch,
Uh-huh.
and like maybe that causes more speciation now.
Yeah, I think fundamentally, like the labs are serving a model, and they don't really know what the end user is going to be asking about. So maybe that's like some part of it, because they kind of have to multitask over all the possible things that could be asked. But I think if you're coming to a business and maybe partnering on some specific problems you care about, then maybe you would see that there. Or there would be some very high value applications that are like more niche. But I think right now they're kind of like going after the totality of what's available. I don't think that the science of manipulating the brains is like fully developed yet, partly.
What do you mean manipulating?
So like, so fine tuning without losing capabilities, as an example. And we don't have these primitives for actually like working with the intelligences in ways other than just context windows. Like context windows kind of just work, and it's very cheap to manipulate, etc. And this is how we're getting some of the customization, etc. But I think if it was, I think it's a bit more of a developing science of how you like more deeply adjust the models, how you have continual learning maybe, or how you fine tune in a certain area, how you get better in a certain area, or like how you actually touch the weights, not just the context windows. And so it's a lot more tricky, I would say, to touch the weights than just the context windows, because you're actually fundamentally changing the full model and potentially its intelligence. And so so maybe it's just like not a fully developed science, if that makes sense, of speciation.
And it also has to be like cheap enough.
Yeah.
For that speciation to be worthwhile in these given contexts. Can I ask a question about an extension to auto research that you described in terms of open ground? You say, okay, well, we have this thing. We need more collaboration surface around it, essentially, for people to contribute to research overall. Can you talk about that?
Yeah, so we talked about our research has a single thread of like, I'm going to try stuff in a loop. But fundamentally, the parallelization of this is like the interesting component. And I guess I was trying to like play around with a few ideas, but I don't have anything that like clicks as simply as like, I don't have something that I'm like super happy with just yet, but it's something I'm like working on the side when I'm not working in my claw. So I think like one issue is, if you have a bunch of nodes of parallelization available to you, then it's very easy to just have multiple auto researchers talking through a common system or something like that. What I was more interested in is how you can have an untrusted pool of workers out there on the internet. So for example, in auto research, you're just trying to find the piece of code that trains a model to a very low validation loss. If anyone gives you a candidate commit, it's very easy to verify that that commit is correct, is good. Like someone could claim from the internet that this piece of code will optimize much better and give you much better performance. You could just check. It's very easy. But probably a lot of work goes into that checking. But fundamentally, they could lie and etc. So you're basically dealing with a similar kind of it's almost actually like looks a little bit like my designs that incorporate an untrusted pool of workers actually look a little bit more like a blockchain, a little bit, because instead of blocks, you have commits. And these commits can build on each other, and they contain like changes to the code as you're improving it. And the proof of work is basically doing tons of experimentation to find the commits that work. And that's hard. And then the reward is just being on the leaderboard right now. There's no monetary reward whatsoever. But I don't want to push the analogy too far, but it fundamentally has this issue where a huge amount of search goes into it, but it's very cheap to verify that a candidate solution is indeed good, because you can just train a single, someone had to try 10,000 ideas, but you just have to check that the thing that they produced actually works, because the 99,000 of them didn't work, And so basically, long story short, is like you have to come up with a system where an untrusted pool of workers can collaborate with a trusted pool of workers that do the verification. And the whole thing is kind of like asynchronous and works and so on. And it's like safe from a security perspective, because if anyone sends you arbitrary code and you're going to run it, that's very sketchy and dodgy. So, but fundamentally, it should be totally possible. So you're familiar with projects like SETI at home and folding at home. All of these problems have a similar kind of setup. So folding at home, you're folding a protein, and it's very hard to find a configuration that is low energy. But if someone finds a configuration that they evaluate to be low energy, that's perfect. You can just use it. You can easily verify it. So a lot of things have this property that, very expensive to come up with, but very cheap to verify. And so in all those cases, things like folding at home or SETI at home or auto research at home will be good fits. And so long story short, a swarm of agents on the internet could collaborate to improve LLMs and could potentially even like run circles around frontier labs. Like, who knows, like maybe that's even possible. Like frontier labs have a huge amount of trusted compute, but the Earth is much bigger and has a huge amount of untrusted compute. But if you put systems in place that, deal with this, then maybe it is possible that the swarm out there could come up with better solutions, and people kind of like contribute cycles to a thing that they care about. And so, sorry. So the last thought is, lots of companies or whatnot, they could maybe have like their own things that they care about. And you, if you have compute capacity, you could contribute to different kind of auto research tracks. Like maybe you care about certain, like you care about like cancer or something like that of certain type. You don't have to just donate money to an institution. You actually could like purchase compute, and then you could join the auto research swarm for that project. So if everything is rebundled into auto researchers, then compute becomes the thing that you're contributing to the pool.
Yeah, that's very inspiring, and it's also interesting. Like I don't know how far this goes, but it is interesting that at least some audience of people, here in Silicon Valley or lining up at retail stores in China have discovered that like having access to personal compute is interesting again.
Yeah.
Right. So maybe they're really motivated to do that for their clause, and then they can contribute to auto research.
It's almost like dollars, the thing everyone cares about. But is flop the thing that actually everyone cares about in the future? Like, is there going to be like a flippening almost of like what's the thing that you care about? Like right now, for example, it's really hard to get compute even if you have money.
Yeah.
So actually, it almost seems like the flop is like dominant in a certain sense. So maybe that's kind of like that. Like how many flops do you control instead of like what wealth do you control? I don't actually think that's true, but it's kind of interesting to think about.
The last thing you released was like a little bit of jobs data analysis.
Yeah.
Is that right? What and might touch a nerve, even though you're just like visualizing some public data.
Yeah.
What were you curious about?
Yeah, I guess I was curious too. Everyone is like everyone is really thinking about the impacts of AI on the job market and what it's going to look like. So I was just interested to take a look, like what does the job market look like? Where are the different roles? And how many people are in different professions? And I was like really just interested to like look through the individual cases and try to think myself about like, with these AIs and how they're likely to evolve, like, are these going to be tools that people are using? Are these going to be displacing tools for these professions? And like, what are the current professions and how are they going to change? Are they going to grow or adjust to a large extent? Or like, what could be new professions? So it's really just like a way to fuel my own chain of thought about the industry, I suppose. And so, the jobs data basically is just a Bureau of Labor Statistics. They actually have percent outlook for each profession about how much it's expected to grow over the next, I think, almost a decade. I think it's a decade, but it was made in 2024.
We need a lot of healthcare workers.
Yeah. So they've already made those projections, and I'm not sure actually 100% what the methodology was that they put into the projections. I guess I was interested to color things by, like, if people think that what's like primarily being developed now is this kind of like more digital AI, that is kind of like almost like these ghosts or spirit entities that can like interact in the digital world and manipulate a lot of like digital information. And they currently don't really have a physical embodiment or presence. And the physical stuff is probably going to go slightly slower because you're manipulating atoms. So flipping bits and the ability to copy paste digital information is like makes everything a million times faster than accelerating matter. So energetically, I just think we're going to see a huge amount of activity in the digital space, huge amount of rewriting, huge amount of activity, boiling soup. And I think we're going to see something that in the digital space goes at the speed of light compared to, I think, what's going to happen in the physical world to some extent. It would be the extrapolation. And so I think like there's currently kind of like, I think, an overhang where there can be like a lot of unhobbling almost potentially of like a lot of digital information processing that used to be done by computers and people. And now with AIs as like a third kind of manipulator of digital information, there's going to be a lot of refactoring in those disciplines. But the physical world is actually going to be like, I think, behind that by some amount of time. And so I think what's really fascinating to me is like, so that's why I was highlighting the professions that fundamentally manipulate digital information. This is work you could do from your home, etc. Because I feel like those will be like things will change. And it doesn't mean that there's going to be less of those jobs or more of those jobs, because that has to do with like demand elasticity and many other factors. But things will change in these professions because of these new tools and because of this upgrade to the nervous system of the human superorganism, if you want to think about it that way.
Given the look you had at the data, do you have either any observations or guidance for people facing the job market or thinking about what to study now or what skills to develop? I mean, we can all go get like, I'm very thankful that I have to like meet people for my job right now.
Yeah.
We get more physical. Yeah.
Could you do your work from home though? I could.
I think there are relationship parts of it that are hard, but most of it I could.
Yeah. I think it's really hard to tell because again, like the job market is extremely diverse, and I think the answers will probably vary. But to a large extent, like these tools are extremely new, extremely powerful, and so just being, just trying to keep up with it is like the first thing. And yeah, because I think a lot of people kind of like dismiss it, or
they're afraid of it,
etc. Which is totally understandable, of course. Yeah, I think like it's fundamentally an empowering tool at the moment. And these jobs are bundles of tasks, and some of these tasks can go a lot faster. And so people should think of it as primarily a tool that it is right now. And I think the long-term future of that is uncertain. Yeah, it's kind of really hard to forecast, to be honest. And like, I'm not professionally like doing that really. And I think it's a job of like economists to do properly.
You are an engineer though. And like one thing I thought was interesting is that like the demand for engineering jobs is continuing to increase.
Yeah.
I can't tell if that's like a temporary phenomenon.
Yeah.
I'm not sure how I feel about it yet.
Yeah.
Do you know?
Yeah, that's like the demand elasticity almost. Like software was scarce, right? And so the reason we don't have more demand for software is just it's scarcity and it's too expensive.
It's too expensive, yeah.
So if the barrier comes down, then actually you have the Jevons paradox, which is like, you actually, the demand for software actually goes up. It's cheaper and there's more
powerful,
software.
Yeah.
The classical example of this always is the ATMs and the bank tellers, because there was a lot of like fear that ATMs and computers basically would displace tellers. But what happened is they made like the cost of operation of a bank branch much cheaper, and so there were more bank branches, so there were more tellers. Is like the canonical example people cite. But basically, it's just Jevons paradox. Like something becomes cheaper, so there's a lot of unlocked demand for it. So I do think that that's probably. I do have like cautiously optimistic view of this in software engineering, where I do it does seem to me like the demand for software will be extremely large. And it's just become a lot cheaper. And so I do think that for quite some time, it's very hard to forecast, but it does seem to me like right now, at least locally, there's going to be more demand for software. Because software is amazing. It's like, digital information processing. You're not forced to use like arbitrary tools that were given to you. That are imperfect in various ways. You're not forced to subscribe to what exists. Code is now ephemeral and it can change and it can be modified. And so I think there's going to be a lot of activity in the digital space to like rewire everything in a certain sense. And I think it's going to create a lot of demand for this kind of stuff. I think long term, yeah, obviously, even with auto research, like OpenAI or Anthropic or these other labs, like they're employing like 1,000 something researchers, right?
Mm-hmm.
These researchers are basically like glorified they're like automating themselves away like actively, and this is like the thing they're all trying to do.
Yeah.
I went around.
Some of those researchers also feel the psychosis, right? Because it's working.
Yeah.
Right. And so they're like, oh, it's over for me too.
I did spend a bunch of time going around OpenAI, and I was like, you guys realize if we're successful, like we're all out of job, like we're just building automation for Sam or something like that, or the board, or I'm not sure, but like they're just building like this automation for the board or the CEO or something like that, and we're all out of our job and maybe contributing on the sides. And so it's kind of like unnerving from that perspective.
Is it okay if I ask you Noam's question?
Mm.
You could be doing that, right? Auto researching with a lot of compute scale and a bunch of colleagues at one of the frontier labs. Like, why not?
Well, I was there for a while, right?
Yes.
And I did re-enter. So to some extent, I agree. And I think that there are many ways to slice this question. It's a very loaded question a little bit. I will say that I feel very good about like what people can contribute and their impact outside of the frontier labs, obviously. Not in the industry, but also in like more like ecosystem level roles. So your role, for example, is more like ecosystem level. My role currently is also kind of more on ecosystem level. And I feel very good about like impact that people can have in those kinds of roles. I think conversely, there are definite problems in my mind for basically aligning yourself way too much with the frontier labs too. So fundamentally, I mean, you have a huge financial incentive to with these frontier labs, and by your own admission, the AIs are going to like really change humanity and society in very dramatic ways. And here you are basically like building the technology and benefiting from it, and being like very allied to it through financial means. Like this was a conundrum that was at the heart of how OpenAI was started in the beginning. Like this was the conundrum that we were trying to solve. Mm-hmm. And so that so it's kind of
it's still not resolved.
The conundrum is still not like fully resolved. So that's number one. You're not a completely free agent, and you can't actually like be part of that conversation in a fully autonomous free way. Like if you're inside one of the frontier labs, like there are certain things that you can't say, and conversely there are certain things that the organization wants you to say, and they're not going to twist your arm, but you feel the pressure of like what you should be saying,
right?
Because like obviously. Otherwise, it's like really awkward conversations, strange side eyes, like, what are you doing? So you can't like really be an independent agent. And I feel like a bit more aligned with humanity in a certain sense outside of a frontier lab, because I'm not subject to those pressures almost, right? And I can't say whatever I want. Or I would say in the frontier labs, like you can have like impact there, of course, as well. So, but there's many researchers, and maybe you're one of them. Maybe your ideas are really good, etc. And maybe there's a lot of decision making to do, and you want to be in a position where you are in the room with those conversations when they come up. I do think that currently the stakes are like overall fairly low, and so everything is kind of like nice. But ultimately, at the end of the day, like when the stakes are really high, etc. If you're an employee at an organization, I don't actually know how much sway you're going to have on the organization, what it's going to do. Like fundamentally, at the end of the day, it's you're not like really in charge. You're in a room and you're contributing ideas, but you're not like really in charge of that entity that you're